All right, welcome back, everybody. We are going to go, let's see, we'll just do this whole page because they all seem pretty together. So we're going to draw a tree diagram for the following scenario, and I'm going to do the fundamental counting principle off to the side. Okay, so Mark's making himself a salad. He's got two types of lettuce, romaine and iceberg, which has absolutely zero nutritional value. It's just water. Two types of vegetables, carrots and broccoli, and two types of cheese, Parmesan and cheddar. This poor guy, he ain't got nothing to make a salad. He can make a garnish. Okay. So remember, we start with our two types of lettuce. So we've got romaine and iceberg. Now, when I do my romaine, it can go to carrots or broccoli. Iceberg has the same option, carrots or broccoli. And then from carrots or broccoli, each one has Parmesan or, help me out here, cheddar. Cheddar, Bob. Give him the cheddar. The high stinky. Okay. Each one has its own type of cheese. So when we finish writing out Mark's choices, we can see 1, 2, 3, 4, 5, 6, 7, 8. So he's got 8 different salad options. Right? Again, we could do fundamental counting principle. 2 types of lettuce, 2 types of vegetables, 2 types of cheese. Okay? 2 times 2 times 2 is 8, which gets me there. So I can go tree diagram or fundamental counting principle. It doesn't matter to me. Okay, what is the probability that Mark will make a salad with romaine, carrots, and Parmesan? So if we look at our tree, so we go romaine, carrots, and Parmesan, well, that is just one full branch. So that is a 1 out of 8 chance that he'll make that specific salad. Okay, are the following independent or dependent? So if we remember from way back, in order to be independent or dependent, when we multiply these two numbers together, it should equal our intersection. So when we say probability of A times the probability of B, okay, it should equal the probability of A and B. Meaning the A doesn't affect B and vice versa. So we go 0.4 times 0.6. Wow, Sean. Good job, buddy. Does that equal 0.24? And it does. So these are independent events. They are independent. Okay. If we roll a die and flip a coin, are those independent or dependent? So you've got to ask yourself, does the dice affect the outcome of the coin? Now, obviously, when you roll the dice, it could clip the coin, but we're going to say we're completely separated in this situation. Okay? Is this independent or dependent? These are independent events. Okay? The coin, the die doesn't affect the coin, and the coin doesn't affect or effect. Come on, English people, help me out. Die doesn't, sorry guys, affect the coin, and vice versa. When you draw a card out of a deck without replacement, draw a card, another, again, these are dependent. Okay, remember that, without replacement or destroyed or thrown away. Dependent. All right. Oof. Okay, when we don't put the card back, we are changing the population. Okay? So when we don't put it back, we went from 52 to 51. So we've got to be careful. When we don't put something back, that is dependent. It is changing the outcome of the next one. 25. Are the following events independent or dependent? Okay, again, remember, so these two multiplied together have to equal the other. So we get 0.8. What are you doing, guy? 0.8 times 0.9. What does that equal? I'm going to go with 0.72. Let's double check in the calculadora. That is correct. 0.72. Okay. These are not equal, so we do not know so we cannot say that they are independent or dependent. Okay, guys, that's going to conclude our video. I'll post a couple more little practice things if you want to work through them. Hey, but do you guys see how I wrote all this stuff out and we did all this work and we showed all this work and all this work was shown on your test on Friday? To get full credit, you have got to show me setup. I have got to see it. Okay, you can't just give me an answer. All right, love you guys. Crush it.